So we've got sand piling into a right circular cone. Okay, right? It's like my hourglass that I like to watch on a Friday night. Okay, at 8 cubic feet per minute. So here's the deal. What unit is always cubic units? Like a length, an area, or a volume, right? So it says sand is piling into that cone at, you guys, this is supposed to say rate. At a rate, at a rate of 8 cubic feet per minute. So, because it's cubic feet, say that, Greer. So, is it V equals 8 or dV dt is 8 if I said rate? The rate that my volume is changing. So, we're going to say dV dt is 8. Greer, the radius is equal to the height. You cool if I just say, okay, R is H? Yes. I don't really know what else to do with that. Then Greer says, how fast is the height changing? Do I want H or do I want dH dt? How fast?
You want dH dt.
Right, because how fast would be the rate? How fast are you going? How many miles per hour? What's your rate? I want to know what dH dt is. I don't know what that is. The moment my height is 5, H or dH dt is 5, Greer?
H is 5.
Agreed. You guys, I apologize also that I didn't give you the volume formula. They will always give us the volume formula of a cone, which is 1/3 pi r squared h. They will give that to us.
One bar. It's like a
Question, if I took the derivative of this like so, wouldn't I have to do fig plus gif?
Yep.
If r is h, but I need h dH dt, what do I want to replace that? Don't I want to make that an h squared?
Can you make it an h cubed?
Yeah, and that's fine. So we could say my volume is 1/3 pi h cubed because my r and my h are the same. Could I have made that an r cubed? I could have, but you guys, I don't have anything about r other than it's the same as h, and I need dH dt. You know what I'm saying, people? Okay, let's go do it. I need someone to help me. What is dV dt if I've got 1/3 pi h cubed? So, you got this. Because you're saying 1/3 times 3 gets me 1 pi h squared. A lot of people forget that squared right there, people. Times, what's the derivative of h with respect to time? Beautiful. Can we plug in some knowns?
Yes.
Do we know what dV dt is?
8.
Pi. What's my h?
5.
Square it.
25.
Do we know what dH dt is? No. What are we going to say my final answer is without a calculator? I'm good with it.
25 pi.
8 over 25 pi. Aww. Okay, here we go. Radius of a circle is increasing at a rate of 0.2. R or DRDT? DRDT is 0.2. Dr. DT is 0.2. What is the rate? Oops, look at what I just did there. What is the rate of the area increasing? What do they want? They want dAdt. Very good, Greer. The instant when the circumference is 20. C equals 20 pi, my bad, or dC dt is 20 pi. She said the instant when circumference is 20 pi. Is that a rate? Nope. So just my circumference is 20 pi. Good, Dar. Okay, Dar. Notice that they didn't give us a formula on this one. If they want dAdt, which is the area of a circle, we got to start with area of a circle. Do you remember what that is, Dar? Area of a circle? She knows it. Area is pi r squared. Dar, you want to take the derivative of that area with respect to time? You got this. The derivative of A with respect to time would be...
dAdt.
Yeah, but my girl Daria wants to get it. The derivative of pi r squared with respect to time, Dar.
So, I'm confused. So, would it be 2 pi r?
Times the derivative of r.
Oh, I see.
That's fine. You got it, girl. So, and again, Dar, the reason that we get to just bring that 2 out in front of the pi is because the pi is just a constant. You did that perfectly. You're saying, okay, we just have like an 8r squared. If I had 8r squared, we would just multiply those together and get 16r. That's why you just brought that 2, brought my exponent of my r down, and then so we took the derivative of the outer, we left the inner, times the derivative of the inner. That's where my dRdt came in. So what I would think of off to the side, Graham, what's up?
Oh, I was gonna say that.
Oh, Graham, what is circumference? 2 pi r. So that's something we got to remember. Circumference is 2 pi r.
Pi times 0.2.
Could I put a 20 pi in right here?
Yes.
Sure. If you didn't think of that, that's fine to say, all right, if those are equal, 2 pi r is the same as 20 pi. Like, circumference is equal to 2 pi r. But I mean, I'm doing more steps than yours. I like your way. I'm just showing another in case people need it. Could I divide by 2 pi and get my r is equal to 10? But Graham Nels, if I put a 10 right here, isn't that really 20 pi? So we're doing the exact same thing. Yes, healed. So we got 2 pi times 10 times dRdt, which we know is 0.2. Again, you might have just written 20 pi right there. Perfect. You guys, without a calc, even if this was, let's say that this was no calc, 20 pi times 0.2, I think people struggle with our decimals. What is 20 times 2? Don't even worry about that. What's 20 times 2? 40. So we'd have 40 pi as my answer. And then this decimal is just saying it was 1 to the left. So I need to take this decimal 1 to the left. And I'd get 4.0 or just 4 pi. Here's Braddock flying a kite. The kite is a constant height. This is where calculus, we're using the real world. We're getting involved in real world, but you guys, we can only have so many variables, meaning your kite, Braddock, will always be 300 feet. It's going to be blowing away from you, but it'll always stay a constant 300 feet tall, okay? We can't have... This is how his kite flies. So, Braddock, do you agree? Your kite, yes, that is always 300 feet. Okay? Here we go. It says the wind is carrying the kite horizontally at a rate of 25 feet per second.
Basically an angle.
Here's, horizontally. I want to name this X and I want to name that Y just because it's like the X axis and Y axis. You down with that? So if it says it's carrying the kite horizontally at a rate of 25 feet per second, dx dt, dy dt, or dz dt is 25.
dx.
Yeah, horizontal rate. Horizontal variables X. The rate of that would be 25. Oh, give me 1 sec. dx dt, we're saying is 500.
Yes.
No, whoa, 25, my bad. Whew.
Why are you saying 500?
How fast must he let out the string? Where's the string, X, Y, or Z?
Z.
Okay, how fast must he let out the string? We want dz dt, right? A rate. The dz dt is what we want. At the moment, yes, Daria, at the moment the kite is 500 feet away from him. Is that kite always going to be 500 feet away? No, that kite is at that moment it's going to be 500. Is it always going to be 300 feet tall? Yes, because that's how my kite works. You guys, the moment, okay, I'm not going to put 500 on my picture because is it always 500 feet away from him? No, but I'm going to just put that little fact up here. The only things I can put on my pic are like this being 300 always. What equation do you think I'd use? If I need a dz dt, you agree I need the derivative of z. Dicey, you're saying I got to go Pythagorean theorem. What would that Pythagorean theorem be, Dicey?
I squared plus y squared.
Love it. Instead of y squared, do you agree his kite's not moving anything? So I want to put a 300 in there because that is a constant. Am I going to put a 500 in for my z? I'm not, because it's not always 500 feet away. Sound good? Okay, Mr. Dice, will you take the derivative of this with respect to time? Por favor, muchas gracias.
Yes. 2x dx dt.
Uh-huh.
Plus 0
Very good. He's saying the derivative of constant 0.
equals 2z dt.
Perfect. Here we go. What's my x?
50. Or 50x.
Because dx dt is 25. So 25 times 2x.
Oh. I appreciate these thoughts. Real fast. Do we know... Wait. We got a 2. Right? We don't know what x is yet, right? But at this moment in time, my y is 300, my z is 500, right?
So 500 squared minus 300.
Yes. So would I technically have to do another Pythagorean theorem of x squared plus 300 squared has to equal 500 squared at this moment in time? You guys, don't do it. Don't do it. What's the shortcut? This is a what kind of triangle? 3, 4, 5 triangle. 3, 4, 5. So it's going to be 400. You want to know what you'd have to do without a calculator to do that? 300 squared is 90,000.
What?
It's the square, and then 500 squared is 250,000. And then x squared is the square root of 160,000 gross, right? And that's going to get me 400 gross. You guys, is it important that we remember 3, 4, 5 triangles on the ACT, SAT, and the AP test? Yes. So this is going to be 400 at that one moment in time. You down with having to find that, Nels? What's the other typical Pythagorean theorem, Pythagorean triple?
It's something like
5, 12, 13. 3, 4, 5, 5, 12, 13s are the most frequently used. There's infinite ones. I mean, they go on for infinity. Okay. dx dt.
50. Or 25.
25.
50 times 400.
The derivative, 2z. What was my z at that moment? dz dt. We don't know. That's what we're solving for, right? Without a calc. 50 times 400, how I like to think about that,
20,000.
is 50 times 4, or 5 times 4, is going to give me 20,000. Keep all those zeros at the end. 2 times 500 is 1,000. Divide by my thou. Wait, why did I just throw a pi in there? Sheesh.
20,000 over 1,000.
Correct? So when 3 zeros cancel out, and we're left with 20.
There we go.
20 equals.
We got the cutest little perfect bowl that's not going to balance because it has no flat bottom. It is shown above. It's a tank. Perfect half a sphere. Has a radius of 6. I'm just going to write some facts down. R is 6. It's losing water. The tank of water is losing. The area of the surface is this. Would you say that that's a dAdt or just an A? Just an A. It's just the area. Okay. H is depth. Do I wish that they did D is depth or H is height? You know what I'm saying? That's kind of annoying. H is the depth. I'm just going to kind of keep that in the back of my mind. When H is 3, I'm going to put that little fun fact out there. When H is 3, the depth, which again is fancy for H, is decreasing at a rate of a half. DH dt, agreed. Positive or negative if it's decreasing. Yes. At that moment. What is wrong with me? At that moment, what is the rate? They want to know what is the rate. Where the area, they want dAdt. You guys are good. Or A prime. You could write it as A prime. I'm down with that. You guys, here's A. Who's going to do that derivative for me? Because we got to then plug some stuff in. Sammy, have you gotten candy yet? Okay, Stevie?
We're going to have to product all this, right?
12 pi is a constant.
Oh, okay. So, 12 pi dHdt. And then minus just, 2 pi dHdt.
2 pi, that exponent would go down by 1. Would I still have an h around?
Oh, no.
What, what's 2 minus 1? So I'd be left with 2 pi what? 2 pi h, then followed by what? Good. All right, can we plug and chug?
Yes, dHdt is negative 1/2.
dH dt is negative 1/2. 2 pi, do we know what h is?
3.
dH dt again is negative 1/2. What's negative half of 12?
Negative 6.
Love it. We got a negative 6 pi. Anything over here cancel out nicely?
The negative 2 and the negative 1.
Agreed. We got 2.5 cancels out. Plus or minus 3 pi.
Plus.
Good, because minus and negative is going to turn into plus 3 pi. Final answer,
Oh, negative 3.
negative 3 pi. Question, why are all these positive?
Because
Because it's asking how fast it's decreasing. So
at speed is.
They already said, we know it's decreasing. We know it's going to be negative. Since they said decreasing, that's why their answer is that positive. Great, and lie. Ooh, 400. Let's go take a peek. Now that we've been talking ladders, ready, Graham Nells? We got this ladder that now we can really picture sliding down a wall, right? So it says, thanks, the top of a 15-foot ladder. Is that ladder changing sizes?
No.
Do you agree? I can say that ladder is 15 feet. That's a constant. I'm throwing it in my picture. All right. It is resting against a vertical wall with the bottom of the ladder on a level ground. All right. The ladder is sliding down the wall at a constant rate
So the wall
of
is
2. Agreed. She said dy dt, and we hadn't even named it y yet, but I like that you did that because, like, if we were looking at an x and y axis, the x is always the horizontal and the y is always the vertical. So I dig that. Thank you, Miss Care Bear. Do you agree that it's going to be negative 2 since it's sliding down the wall?
Yes.
Okay. It says, at what rate in radians per second? They want to know a rate. At what in radians per second is the angle between the bottom of the ladder and the ground? You guys, they're asking about that angle right there. Between the bottom of the ladder and the ground. What letter did I just make that? What Greek letter? Theta. I did. At what rate is that angle changing? What do they want? Do they want theta? They want d theta dt. I'm going to actually put that up here. This is what we want. At the instant, the one moment in time, because this ladder is moving, he is falling, but at that one moment that the ladder is 9 feet, that x is 9, am I going to put that on my picture though?
Yes.
Is it 9 the whole time?
No.
It's not 9 the whole time, so I'm going to put that off to the side. I will put it on eventually, but not for my initial equation. Okay, you guys, you agree we want d theta dt? Yes. I need to come up with an equation that involves theta. If I said x squared plus y squared equals 15 squared, that's true, but that's not going to help me with an angle.
tangent of theta equals.
Okay, ooh, I hear two good things. So I heard tangent would be opposite over adjacent, right?
Yeah, or yeah, it'd be easier.
Or, lie, the sine of theta is opposite over hypotenuse. Lie, do you agree they gave me dy dt? So I like that I could use that when I've got a constant is nice as well because the derivative of a constant is 0. Like it's one less variable to have to worry about. I like it. What's up, Stevie?
You could plug.
So if we said the sine of theta is opposite over hypotenuse, so katoa, what would I say for my opposite?
Negative 2.
Careful. My opposite is y over my hypotenuse, 15. Is that the same as saying 1/15 y? Yeah, I think that's important. That's like on your quiz when I had 3x over 4. The derivative of 3x over 4, it's way easier to think of that as 3/4 x. The derivative of that's 3/4. If I kept it like this, I'd have to do quotient rule. If I kept it like that, I'd have to do quotient rule. Gross. So now let's go find the sine of theta, the derivative of that with respect to time. Derivative of sine, cosine, leave the angle, times the derivative of the angle.
D theta dt.
Beautiful. We just took this derivative. Hey, Greer, you just said d theta dt, which I'm glad because that's what we need, right? You guys, derivative of 1/15 y with respect to time.
Negative times -2.
Wait. What's the derivative of 1/15 y? 1/15 dy dt. Oh, my Lanta. Okay, you're right. This is the last one. So now we need d theta dt. Greer, you were saying dy dt we can plug in. I agree. So we've got 1/15 times -2. We got our d theta dt. We don't know what that is. Can we go find the cosine of y? The cosine of y. So what is cosine? What do I need? Adjacent over hypotenuse. At this moment in time, am I allowed to use that 9 now? Yes. So my adjacent is 9. My hypotenuse is 15. So I'd say that that's 9/15. Let me say that one more time. On my picture, my x is 9 at this one moment in time. I didn't have that in earlier because it's not constant. Cosine, is adjacent over hypotenuse. So I just replaced cosine of theta with 9/15. Dividing by 9/15 is the same as multiplying by 15/9 because this is non-calculator. These cancel. I'm left with d theta dt. These cancel. And I'm left with
1/9 times -2, which would be -2/9, but it's a rate.
just kidding.